Hey guys, my name's Justin and I'm with Pro-Bel Enterprise. So today I'm going to be going over the basics of fall protection design, but before we get into that, let me just tell you a little bit more about myself. I'm a junior designer for our fall protection, and I also work in business associate development, which essentially means it's my job to arrange our free design services for any eligible projects, and honestly that includes most projects within North America. I've arranged designs for projects for everything from retrofit in small schools and new construction projects like apartments and airports to even large scale projects for name brand hotels. So if you have a project and you're confused about fall protection, I'm happy to answer any questions. I can even arrange a consultation if you need it for no charge. And honestly, like I said, most projects are going to be eligible for free designs. So there's no harm in reaching out. Okay, so first things first, you gotta know your scope. So for this demo, we're gonna be doing a hospital that only requires fall protection, not suspension. We're gonna be making one that does cover window washing systems in the future though, so definitely stay tuned for that. But until then, we have resources on Pro-Bel's website and our contacts also in the bio if you got any specific questions. So, since we know that our scope is only going to be fall protection, then it's time to review the relevant information in the drawings. So, design for fall protection, we need the elevation, roof plans, isometric, structural plans, anything you can get, and all the details for the fall protection if they were included as well. So, most regions follow the same guidelines for fall protection, but Canada and some other states are going to have slight tweaks to the requirements. So, you need to confirm if the region you're working in does follow the standard protocol for fall protection or not. So always double check. Measure twice, cut once. The structure of the roof is going to determine both the placement of the anchors and what type of base they'll require. So, for wooden structures, the anchors can usually be placed anywhere, but not always, so you need to check. For cement, though, they can be cast in place pretty much anywhere on the roof. Unfortunately, for steel, they can only be placed on beams, which can make it a bit trickier if there's a lot of interference on the roof, HVAC units, things like that. So any other equipment or other interferences in the roof are going to need to be considered when you're planning the layout. If there's equipment near the roof edge that blocks a horizontal lifeline from being implemented, its anchors got to be 6 feet on center to a maximum of 10 feet, no more. Next, you got to review any elevations that would alter the drop distance. If the roof plan doesn't encompass all the roofs on the building, you're going to need to merge them together in a separate document before you can begin that design. So, calculate the drop distance on all elevations to make sure that the faces require fall protection. So, the required height for a parapet, which is going to eliminate the need for roof anchors, is 42 inches from the finish of the roof. And, again, this is going to vary in some regions, but that's the standard requirement for most states. So when a parapet is under 42 inches and rooftop work is going to be expected to occur within 6 feet of the roof edge, safety and tie-off anchors are going to be needed. Okay, so once you reviewed all these factors, it's time to create a new design. You should separate all the roof plans into a new document to begin the design process. And if the different roof elevations aren't all on one document, you gotta merge them. Have any relevant documents such as roof details, elevations, landscaping if it's applicable to the roof, isometrics, overall building section, and any other plans that would impact the roof, make sure you got them all together in one. So the way we do this is we set our anchors back 8 foot, 9 to 10 feet, and then we need to first set the scale to this. Okay, 1 8. Okay, so the way to make sure that the fall restraint system works, 8 foot 9, 8 feet, 9 feet, something like that. But for our purpose here, we're just going to use 10 because it's a nice round number. So I would create one measurement just like that. We're going to have our measurements set out like this. So this particular drawing is an example of a fall restraint system. So we're just going to add one thing to it. But so that's what we do with that. So we're going to measure to the edge, both sides. We set our anchors along those measurements. Now, the only caveat is the length between anchors cannot exceed 30 feet. So this one anchor is technically unnecessary in the center because our span between the anchors on the long side is less than 30 right here. But we'll just redo that really quickly and it should be all good. And we know that we have one anchor that's supposed to be there, and we're going to bring our other anchor down by copying it over. And
That's where we're going to copy over there, just another anchor. However, because this anchor is necessary, we need to add one anchor at a 45-degree angle, or if it works out to be 45, because we're at exactly 10 and 10 with the distance here, and it's a pretty square building from this anchor to the corner. We're going to add in an additional anchor here at the corner, which is within 6 feet, which is then going to allow the worker to, detach from that double lanyard. The double lanyard and attaching with this anchor, then coming back, detaching here, and they can reach, all this stuff here, and that's still within that area. But because they're attached to an independent anchor, we can place it much closer. So that's great. So it just needs to be within 6 feet of the closest anchor, because this anchor right here, this then falls within the fall hazard zone, which is 6 feet inward from the building edge. If the parapet's not tall enough. So even though this anchor is now within the hazard zone, the fall hazard zone, it's still within a 6-foot reach of another anchor that is outside of the hazard zone. And so, that's the design approach to corners. So, from there, let's do a longer one here up at the top. So, up over here. So first, let's start with the bigger part. On larger footprint roofs, we usually try to measure the maximum span of a fall protection system so that we have, all the information we need. But of course, doing something like that is also going to come with a few little intricacies and quirks here and there. So first thing we got to do is figure out any elements that we can use, like a screen wall, which this drawing does have, which will allow us to kind of offset the amount of clients' wall anchors they would need. And that's also going to reduce the penetrations in the roof system with those anchors and things like that, which is going to minimize any potential leaking or, just really cut down any kind of rooftop problems, structural things, stuff like that. So the more we can prevent penetrating the roof, the better. And so we do that with wall anchors. So in this case, we have a screen wall over here with vertical posts that are, typically set at like 14 feet. And, that works out great actually. Like I was saying earlier, since the distance between the two. And since the maximum span we can have for anchors is 30 feet, but for a cable system, we don't have to be as much. So I'm going to start placing my wall anchors in at every single vertical post that would be usable for this. So the best case scenario for a wall anchor is at a screen wall is that we use either the horizontal beam or the girder I-beam. So not every girder though is meant to take any load, let alone like even something light. So at this point, we're just going to be ignoring those for now, and we're going to be placing anchors at the vertical points. So we got one anchor there, and we're just going to repeat basically what this drawing has for most of these situations. I'm going to place another one there, another one here, one more over here. Now, if we don't know what the spacing is, we won't have like a nice convenient measurement there. So what I like to do here is just add a circle with a radius of 30 feet. And then, so I don't need that to be a 30. Basically, I know that if I place an anchor within this radius, where I see it here, I know that my anchors, and basically, I know that if I place an anchor within this radius here, I know that my anchors are going to be within that 30-foot span, so there's not really any issues there. And so the way that I'll do that is I'll copy one anchor, then I'll move the circle here, then I'll copy the anchor along that same axis, and so on and so forth. And so, as you can see, here we are. We're not going to continue the line all the way to the corner like we would on, like a normal project, because we have quite a big distance to cover with just a single line. So we're going to make a curve into the line that will kind of look like this. We'll go over here and up, but we'll draw our cable on in a moment. Don't worry, it'll make more sense at that point. So let's just ignore the left side for a moment, and we'll continue on over here. I can't just continue along this line, even though I'd like to, because I want to be able to catch this corner as well with the same cable, and then not have to do this kind of, come over the side sort of thing. Like, oh, I would have to redo the entire left-hand side if that was the case. So, I'd like to start with this corner here that I know, and I'm very restricted about where I could put an anchor on it. So, for wall anchors, I'm going to switch over to roof anchors instead. And for this case, we're going to assume that this is a concrete slab, 8-inch thick concrete slab, all different roof types, but this will allow us to place anchors anywhere we want within reason. Of course, if the structural components of this roof was, say like a steel structure, then we try to match any structural components that are already existed or planned to be placed onto the project. We can weld the anchors onto the existing steel. Fortunately, this isn't always an option depending on the material the roof and project everything is made of. And if there's, no available steel, we're going to ask the contractor and the client to be aware that, additional steel will be required. And if they say, oh, that's too much, then we'll have to come up with another solution. But we usually tend to just wait, but they don't really leave us much room for our equipment. So what we have to do is, we've got no choice but to put our equipment within this fall hazard zone here. Sometimes in rare cases, if you're lucky, clients are understanding where they can condense the spacing and give us a bit more room. But for this case, let's assume we already had the conversation and the client said, no, we can't really move that equipment. And so that being the case, we're just going to first take another measurement. And now we know that we have a 4-foot clearance between the edge and the solar panel. And so our equipment can be as close as 18 inches away from any actual building obstruction to allow for like proper waterproofing or weatherproofing, things like that. So with the 18-inch measurements, so what I would like to do is place my equipment halfway between our 16 and 18-inch markups and the solar panel. So the easiest way to do this is I'll just make a measurement and I'll align my anchor point to the middle right here. Now, it's the size of the line symbol doesn't really mean anything, so you can just ignore that. But the anchor itself is a 4-inch diameter maximum. And so we're going to stay as, close or as possible or symmetrical as possible on both sides. So I'm 9 inches away from the solar panel, and I'd like to keep that 9 inches away from this side as well, just to be square, at least to stay consistent on the plan. Okay, so I know that my roof anchor needs to be in that location. And, I actually don't need these dimensions anymore because I can actually just copy and adjust anchors along the axis by using the built-in Bluebeam tools. So at this point, we're going to convert from doing wall anchors to a roof anchor here. And so the cable continuously is going to go through all of these. So from here, I'll measure another 30 feet. And so, yep, that's around here. But I know that I want to put an anchor here in the corner at 8 feet. And then, because I know that I'm well within my parameters, it's all good, but it is still a little further away than we would like. You can see here. So what we'll do is we'll add an additional anchor right here in the middle, and we can just equally distribute that just like that. There you go. So we're going to continue off of this corner before we start placing a cable. We're going to measure down 60 feet, because of course 60 is obviously just 30 times 2. And so that would reduce and actually allow me to use the minimum amount of anchors for this whole span, which clients always love. So what I would do, because I can just copy one anchor here somewhere in the middle, and then we'll just distribute them equally afterwards. And with that 60-foot measurement, that leaves us with just around 8 feet, that's actually fantastic. That works out great for this building. And we'll delete these measurements afterwards. We can do that now even, but what we're going to do is select all 3 of these and distribute them equally. So from this side on, just a quick measurement here to see whether or not I can put stuff here in this area without having the line go across, but usually anything above 10 feet should be totally fine. All right. So I would like to go around this corner here, but we'll have to, for this, we'll just have to leave it to see if it's still doable at the end. So what I can do is kind of, match what already exists on this drawing. I mentioned earlier about wanting to make sure things are symmetrical as possible. And so I'm going to bring one wall anchor all the way at the bottom and place it right here on this vertical post. So I know that I need to have an anchor right here. And so what I can do is I can select both of these and select align vertically. And then I just measure to see, how much space do I have? It's 45, which, obviously that's over 30, so we're going to need to have an additional anchor. So we'll just follow along that here. And all this section over here is all good. There's nothing that we really need to worry about, so we can kind of just pass over this part. However, this drawing here does look like it has, in blue here, these look like they're duct units or maybe some kind of other HVAC type things. And so because we're not too sure what's going on with there, those things happen with drawings. And we have things like the elevations and sections aren't super accurate because these drawings are early stages. So you plan around that, and to be safe, we're going to stop our cable system on this anchor right here. So with that said, our anchors are already all set, so we can start measuring the cable, which is going to start with our polyline measurement tool. That's this over here. So it's what I like to use because it automatically gives me measurements instead of having to, put a line here, measure them, add them all together, things like that. So what I would do is I would just go around and basically just hit every anchor point that's at a corner. Just going to snap it on. Have one corner right here. Then we're going to come all the way up. Snap that on. Put it onto this roof anchor. And, again, there needs to be 18 inches away from any actual roofing element for safety. And so that way it allows for proper weatherproofing and things like that. So we're actually going to divert the cable. This one goes fine because it's in a straight line. But we are going to stop the cable line right here because our maximum allotted cable run is 300 feet on the dot. And this works out perfectly for us because we actually end up just under 300 feet. And so here we have the last part of the roof over on the left side. So we got to use all of the steps, the tips and tricks, everything I taught you to place roof anchors around here to complete that final side, and we'll be all done with this project. Okay, just finishing up now, and so we made sure to follow all of those steps that I taught you about here, and so the roof is finally completed. It's all done by the incredible trained professionals here at Pro-Bel. This roof is fully OSHA compliant and completely fall protected to ensure the safety of everybody, workers, window washers, whoever. So, please remember though that doing drawings and things like this should only be attempted by a trained professional. So absolutely reach out to Pro-Bel if you have any questions or concerns or you'd like a quote on your own. So there we go. Thank you so much for coming along with me to this. Fall protection is essential for keeping rooftop workers safe, and of course, any design needs to be reviewed by a professional to ensure the design is optimal with no risks in place. If you aren't in the fall protection industry, then give me a call or email. I'll review your building, and I can even set up a consultation with a lead designer if you'd like. My contact information is going to be in the bio below, so please feel free to reach out. We'd love to hear from you. In addition, when you reach out, most projects actually do qualify for free designs as well, so there's really no reason not to. So, take care. I really hope you learned something. And until then, make sure to keep Pro-Bel in mind for all of your fall protection needs.